Okay, part 4 of the parabolas section. What we learned about in part 3 was how to move parabolas around. Well, we learned how to move them to the right anyway. We learned that if I have a parabola that is the graph of a function of the form y of x equals k x squared, where k is clearly a positive number here, although it doesn't matter if k is negative. I would just draw it slightly differently. The theory still applies though. Everything's still going to move across. So if I have that graph of the function y of x equals kx squared, then if I want to move this graph across by, there, it looks a little wonky. If I want to move this graph across d units to the right, so let's suppose that has a distance of d, then I can do that by simply subtracting d off of x before I put it into my function. Again, I'll call this one y1 of x, and the next one I'll call y2 of x. I'll write it over here because I'm out of space. y2 of x is going to be equal to y1 of x minus d, which is going to be equal to k times x minus d, k times x minus d squared. So that's going to be my y2 of x. It's the same thing, but I put x minus d into the function y1 of x. And that means before I get the same output, I need to move d units to the right. And so what that does, it has an effect of translating the entire graph of the parabola d units to the right. And so it's going to look like this. That really should go through that point. That's a sloppy drawing. Hope you get the idea though. So it has the effect of shifting everything d units to the right, because whatever this output is, I'm going to get exactly the same output when I move d units to the right if I have subtracted d from x before putting it into the function. So that's what we learned last section. Well, how do we... Okay, so that's all well and good. How do we move our parabola to the left? So let's just suppose we're in the same situation. This is the x-axis, this is the y-axis, and again we've got our parabola. It's not very good. Let's see if I can draw a better one. Marginally better. So again, we've got our parabola y1 of x equals kx squared. How do I move this thing to the left by, say, d units again? Well, if I want to move it to the left, basically the thing I want is I want y1 of x minus, no, I want y1 of x plus d, don't I? I want y1 of x plus d. That's going to be equal to k times x plus d squared. Why do I want, so I'll say that's y2. Why do I want y1 of x plus d? Why is that the thing that I want to move my y1 parabola to the left? Well, I don't know, let's say if I have negative d. So let's say that this is negative d. Well, when I put it into my y2 function, I want y1 of 0 to come out. So I want my y2 function to be equal to 0 at that point. And the only way to do that is if I add d to x before putting it into the y1 function, because negative d plus d equals 0. And similarly at every point, I don't know what this point is, but if I put them into my new parabola, wait, is that what I want? No, this is what I want. I want this one for the other one. So if I put this guy into my new parabola, then I want to get this thing out of it. Well, the only way I'm going to do that is if I add d to that point before putting it into my function y1. So that distance there is d. Okay, so that's that's what we do. We add d to x before putting it into the function y1. And that will shift the parabola across by d units to the left. We'll come d units, excuse me. We'll go d units to the left if we add d to our x value, to our input value, before putting it into the function. This is the thing we get out. So this is y2. So if you want to move your parabola d units to the left, you simply add d to x before putting it into your y1 function. And if you want to move your parabola d units to the right, you would simply, running out of room, you would simply subtract. So this is y3 of x equals k times x minus d squared. So you would simply subtract d from x before putting it into your y1 function, because of course this thing here is equal to y1 of x minus d, because when you put x minus d into y1, you get k times x minus d squared. So subtracting d from your x input before putting it into the y1 function means that the graph is moved across to the right by d units, because then you get y3 of x is equal to k times x minus d squared. And yeah, and adding d to your function like we did up here, adding d to your x value before putting it into your function like we did up there to get k of x plus d squared, well, that's gonna move your function d units to the right. Sorry, d units to the left. There. That's going to move your function d units to the left. Okay, so that's how to move the parabola across in either direction. And yeah, I don't think I have anything else to say about that. So see you in the next part of the parabolas. There's still more of this chapter. Parabolas is a pretty big section, but yeah, I think we've covered more of the. Well, we're about halfway through. Anyway, see you next time. Thanks for watching.